So in this class, we will discuss a problem on viscosity, which makes use of the important law, that is Newton's law of viscosity, which is given by tau is equal to mu into dv by dy or mu into v by y. So very important type of problem. So the problem runs like this: a cylindrical shaft of 90 mm diameter rotates about a vertical axis inside a fixed cylindrical tube of length of 50 centimeters and 95 millimeters inner diameter. You can see here, I have written this sketch here. So this is the shaft, inside shaft, cylindrical shaft, and outside is the tube, that is also cylindrical tube. So they have given the diameters of both. So the inside shaft diameter is 90 mm. That is small d value is 90 mm, and outside tube diameter is 95 mm. That means the difference between the diameters is only 5 mm. So let us take that this gap is 2.5 mm. So 2.5 mm this side and 2.5 mm this side. Next, if the space between the tube and the shaft is filled by a lubricant of viscosity 2 points. So here what he has given here is this gap is there, this gap is filled with a lubricant oil of viscosity 2 points. 2 points or it can be taken as 0.2 Newton second per meter square or Pascal second. So oil is there, oil is there in that gap. That means in plan if you see, so this is the shaft, cylindrical shaft, and this is the tube. This is the tube. So in between these two, you have the lubricant of viscosity mu, which is given as 2 points. Now the thing is, what we have to find here is find the power required to overcome viscous resistance when the shaft is rotated at a speed of 300 rpm. Suppose if the shaft is rotated with a speed of n, that is 300 rpm, so what happens here, you can see this diagram, the shaft is rotated with a speed of n rpm, that is 300 rpm, definitely there will be a torque that is going to develop. Torque is going to develop in the when it is going to rotate like this. Due to that torque, there will be a development of a tangential velocity or linear velocity denoted by V here. So what we have to find here is what is the power that is required to overcome this viscous resistance. So when it starts moving downward, viscous resistance will be there here in the form of shear stress like this. So it will be there in the opposite direction of the movement of the shaft. So what is the power that is required, P that is required to overcome this viscous resistance? So this is the given problem. Now let us write down the data, whatever data is given. So speed of the shaft n is 300 rpm, revolutions per minute. Diameter of the inside cylindrical shaft is 90 mm, that is 0.09 meter. Please note that all the units you have to convert to meters, seconds, newtons. So these are the SI units. Be careful here. Then capital D, that is the diameter of the cylindrical shaft, outside cylindrical shaft 95 mm, 0.095 meter. The gap Y, as I already told, that is capital D minus small d divided by 2, which comes out to be 2.5 mm or 2.5 into 10 power minus 3 meter. Everything should be converted to meters. And of course he has given the value of dynamic viscosity as 2 points, which you can write it as 0.2 Newton second per meter square or Pascal second. So because 1 Newton second per meter square is 10 points, 2 points is this much. So these are the conversions we have to make. Now the question is, we have to find out P. So to find out P, we have to move in this order. So see, first what you do is, you write down all the formulae which are useful to solve this problem. So we know that the power is given by 2 pi T by 60, which will be in watts. Please note that here T is the torque that is going to develop due to the rotation of that shaft. So this is torque. which is expressed in Newton meter. N is the speed. And this torque is given by whatever force with which that shaft is moving multiplied by the radius of the shaft, that is small d by 2, diameter divided by 2. That gives the torque, and this force is given by shear stress multiplied by the area over which it is acting. So please note that here the area is this circumferential area. Please note that area we have to take circumferential area. So or you can write it as surface area. Outer surface area of the shaft. The outer surface area of the shaft is given by pi into d is the circumference, L is the length of the shaft. So pi into d into L gives the surface area of the shaft. So tau into pi dl. So that value will be in newtons. Then the shear stress, whatever shear stress that is going to be induced in the direction opposite to the direction of motion of the shaft, it is given by the Newton's law of viscosity. So this is the Newton's law of viscosity. Tau is equal to mu into v by y. When y is very small, we can write dv by dy as v by y. So according to Newton's law of viscosity, tau is equal to mu into v by y, where v is the linear velocity, y is the gap, mu is the dynamic viscosity. And here to find out this v, since n is given, there is a relationship between v and l. So this is the relation. Radius, that is v by 2 into 2 pi n by 60. Please note that this 2 pi n by 60 can also be called as omega, which is called as the angular velocity. So velocity you can express in three ways. This angular velocity is expressed in radian per second. See, velocity can be expressed in three ways. One is omega, angular velocity radians per second. Another is n in revolutions per minute. Another is linear velocity, tangential velocity in meter per second. So the relationship between those three is like this. V is given by omega, that is this 2 pi n by 60 into d by 2, where omega is 2 pi n by 60. So this is the relation. So you should keep it in mind these relations, because they may give the velocity in any form. They may give in radian per second, or they may give in RPM, or they may give in meter per second. So you should be in a position to convert one unit to another unit. So these are the formulae we have to use to find P now. Now how to proceed? So to proceed with the problem, we have to move like this. So first we have to find V, then tau, then F, then T, then P. So this is how we have to move. So to find P, we have to start from V now. So let us proceed in the same lines I have written there. So V is given by d by 2 into 2 pi n by 60. Substitute the values. So d is 0.09 meter. So there is in meters. All these things I have written here. You have to substitute there into pi into n is 300 rpm divided by 60. So here what happens, this 2 and 2 will get cancelled. That's what I have done here. So this becomes 1.4137 meter per second. V will be in meter per second. Then second formula is this. We have to move backwards like this. Tau is equal to mu into V by y, which is the Newton's law of viscosity. So here mu you have to substitute in Newton second per meter square, not in points, because this is the SI unit. So 0.2 into V we have found out as 1.4137 divided by y is the gap. So this gap y should be in meters. 2.5 into 10 power minus 3 we have to substitute, and this if you simplify 113.1 Newton per meter square or pascals. So this is the unit of tau. Then after tau we have to find out F. So F is tau into A, where A is once again surface area pi dl. So tau into pi dl. Tau is 113.1 into pi into D is once again 0.09 meter into L is 50 centimeters. When it is converted to meter, it is 0.5. So L is 0.5 meter. So if you simplify this, you will get 15.99 Newton. So that is the force with which this shaft is moving downwards. Then we have to find out T, force formula, F into d by 2. That is the torque induced, which is given by F is 15.99 into once again D. So this is radius. Radius is expressed as diameter divided by 2, 0.09 by 2. You are going to get 0.72 Newton meter. That is the unit of torque. Then finally, P can be found out by using 2 pi nt by 60. So 2 pi into n is 300 into T is 0.72 divided by 60. So 22.62 watts. So this is the final answer. So this is the power that is required to overcome the viscous resistance offered by the movement. So to overcome this viscous resistance, some power is required to move the shaft. That power required is 22.62 watts. So this is how we have to analyze the problem. So in the second problem, so suppose in the above problem, if I change some of the data, if the small d I will take 300, that is the diameter of the shaft I will take 300 mm, diameter of the tube I will take as 310 mm, length of the shaft I will take 0.3 mm, 0.3 meter, that is 300 mm. Then torque I will take 1 Newton meter. Torque is given here and omega is given here. Angular speed is given 2 pi radian per second. What is the value of viscosity of the lubrication oil which is filled in between the shaft and the sleeve or the tube? So here mu is unknown and torque is given. So like this they may give any data, they may ask you to find any unknown thing. So anyway, you should know all these formulae. Whatever is known, so those formula you have to start applying. Now here, since mu is unknown here, what is the formula to find out mu? As per Newton's law of viscosity, tau is equal to mu into V by Y or dV by dy. So here mu is unknown here, therefore mu is equal to tau divided by V by Y. So that is the formula. So the same formula, since mu is unknown, tau into y divided by v, it will come here. So tau into y by v. So this is the formula I have to use. But here tau is not known, y of course is known, v we can find out. So now let us find out tau, y and v. Then we will substitute here in this formula 1 and we will get the value of the viscosity now, the viscosity of the oil. So first I will take the data of T now. So T is given as 1 Newton meter. We know that T is equal to F into D by 2. So from this we can find out F here because D is known, T is known. So F is equal to 2T divided by D. So which comes out to be 2 into T is 1 Newton meter divided by D is 0.3 meter. So this is 0.3 meter. Please note here 0.3 meter. So if you substitute that, you will get 6.67 Newton. So this is the force in the second problem that is required in the second problem. Then the gap, this gap between the shaft and the sleeve, y value is given by once again capital D minus small d divided by 2, which is 310 mm minus 300 mm by 2. In meters it comes out to be 0.005 meters. Then since omega is given, he has given omega value, that should be converted to V. So y is known, F is known. Now V we have to find out. V is given by this formula. So d by 2 into omega. 2 pi by 60 is omega. So d by 2 into 2 pi in radians per second, you will get 0.94. Here pi is of course 22 by 7. So 0.94 meter per second is the tangential velocity of that shaft. Now tau I need. So once I get the value of F divided by A, force divided by the surface area, see here. So tau into A is F, therefore tau is equal to F divided by A. So where A is once again pi into D into L. Now substitute the values. F is 6.67 divided by pi into D is 0.3 meter, L is also 0.3 meter here. Okay, both are same here. So if you simplify, you will get 23.6 Newton per meter square. Now we got all the values. Tau value we got, y is known, v is known. Substitute the values in SI units in equation 1 to get the value of mu. So this is the thing about Newton's law of viscosity. So mu is tau into y divided by v. So tau is 23.6 Newton per meter square into y is 0.005 meter divided by v is 0.94 meter per second. If you simplify that, you will get the value of viscosity in Newton second per meter square, 0.1255 Newton second per meter square. If you want the value in poise, just multiply this by 10. So 1.255 poise because 1 Newton second per meter square is 10 poise. So this is the viscosity of the fluid that is required in the second problem. So any data may be given among all these parameters, any parameters they may give, you may be asked to find the unknown parameters.